Okay, class, good afternoon. So this is a special topic in power plant engineering. So this is under power and industrial plant engineering. So this is for ventilation system. Okay. So we have here for refrigeration machinery rooms. Okay. So actually, class, this is obtained from Los Angeles, California Mechanical Code. Okay. So refrigeration machinery rooms. Refrigeration machinery rooms shall be provided with dedicated mechanical exhaust systems. The exhaust systems shall have the capacity to provide emergency purge of escaping refrigerant at the rate of 30 air changes per hour, or ECH. Okay? So for ammonia or for other refrigerants as determined in accordance with equation 1107.2. Okay? So this is at the Mechanical Code, or Los Angeles, California Mechanical Code. Okay, so the definition is equals to Q equals to 100 square root of G, where the Q now is the airflow rate in cubic feet per minute, where G is the refrigerant mass in largest system in pounds. Okay, so take note, class, of the equation. That is very easy. Okay, that is Q, or the airflow rate, is equals to 100 multiplied by the square root of the mass of the refrigerant. Okay? So, for natural ventilation, so where a refrigerating system is located outdoors more than 20 feet or 6,096 millimeter from building openings and is enclosed by a penthouse, lean-to or other open structure, natural or mechanical ventilation shall be provided. So the requirements for such natural ventilation shall be in accordance with the following. Okay. The pre-aperture cross-section for the ventilation of a machinery room shall be not less than as determined in accordance with equation 1007 or 1107.3, where F now, or the pre-opening area, is equals to the square root of G. So again, square root or G is the mass of the refrigerant. Okay? So this is the second equation, class. Okay? So discharge capacity of relief valve. Okay. So the minimum required discharge capacity of the pressure relief device or fusible plug for a pressure vessel shall be determined in accordance with equation 1113.5, or C is equals to F D multiplied by L. Okay, so where C is the minimum required discharge capacity of the relief device expressed as mass flow of air. So that is, of course, in pounds per minute or in kilogram per second. So where D is the outside diameter of the vessel, so that is in feet, and L is the length of the vessel, of course, in feet or in meters. So where F now, of course, is the factor dependent upon the type of refrigerant from table 1113.5. Okay? So, another. So, we have here the table, of course. So, for the relief device capacity factor. Okay? So, F. So, we have here for R23, 170, 744, 1150, 508A, and so on and so forth. Okay? So, R13, R14, 718. So, we have here the value at the right side, of course, of the slide. Okay? So, let us now take an example of the previous equation. Okay? So, we have here compute the airflow in cubic feet per minute of mechanical ventilation required to exhaust an accumulation of refrigerant due to leaks of the system capable of revolving air from a machinery room for a mass of 4 pounds refrigerant. Okay, so we have here the option A, B, C, and D. Okay, so let us now solve for the equation. So that is the first equation, of course, in the presentation. So that is Q is equals to the square root, or 100 square root of G. Or simply, so square root of 4 is equals to 2 times 100. That is 200 cubic feet per minute. So that is now the required air flow rate. Okay? So another, so we have, okay, so number 2, compute the pre-aperture cross-section in square meter of the ventilation of a machinery room if the mass of refrigerant is 9 kilograms. Okay, so we have here the option point or A, B, C, and D. Okay, so again for G is equals to 9, so that is 2.205 pound per kilogram. Okay, so that is 19.845 pounds. Or F is equals to the square root of G. Okay, so 19.845. Therefore, F now is equals to 0 point or 4.45 feet or square feet rather, and equal to 0.41363 square meter. Okay? So another, so at 29.53 inches by 39.37 inches, pressure vessel contains ammonia with F equals to 0.041. Compute the minimum required discharge capacity of the relief device in kilogram per hour. Okay, so we have here the option also. So the equation is equals F DL. So equation 1113.5. Okay, so getting now the minimum required discharge capacity, substituting values. So C now equals to 110.765 kilogram per hour. Okay, so that's all class. Thank you very much.